The Black Sea, mostly rough, big and frequent waves, sometimes shrouded in mist and shades of black and gray. Yes, there's a question you probably heard whispered about this sea for a long time. When will the Black Sea explode? Is it a clickbait? First, it sounds like a scene from a disaster movie. Giant waves, tsunami, gas shooting into the sky, chaos on the shore. The curiosity behind this question is generated totally in scientific observations. Is really the Black Sea different from other seas? Don't just look at its surface, you should go to its depths. The secrets are there. Is the word explode an exaggeration? Is science shows that the situation is fully under control? To understand it, first we need to explore some terms like geography, layers, and depths. Why does the surface of Black Sea look so calm? Why do northern winds sometimes stir waves but never cause a catastrophe? The answers are hidden in the layers beneath the surface. For a long time, the secrets of the Black Sea have fascinated researchers. Each layer says something different. Fish life in Black Sea is near the surface. Microscopic organisms stay in the middle layers, and in the deep, methane-filled, oxygen-free, light-free layer. When you think all the layers together, some may ask, could it explode? But the data is insufficient to answer the question yet. Now, let's start from the point where the Black Sea is and what is the reality. Stretching from the Balkans to the northern coast of Anatolia, from the Caucasus to Eastern Europe, you will see the most enclosed sea in the world. And this unique nature allows it to become a phenomenon. The Black Sea is a unique sample both geographically and environmentally. It is bordered by several regions. Each has its own characteristics. The Balkans to the west, the northern coast of Anatolia to the south, the Caucasus Mountains to the east, and the vast plains of Eastern Europe to the north. This location makes the Black Sea a crossing point between continents and climates. It receives fresh water from many rivers, the Danube, Dniester, Dnieper, and others. These rivers bring nutrients into the sea, feeding the habitat from the surface to the deep layers. Unlike oceans that are connected freely around the globe, we may say that Black Sea is partially enclosed. The two significant connections are the Bosphorus Strait into the Marmara Sea and then the Dardanelles into the Aegean Sea. These passages control the flow of water, creating an extraordinary balance between salt water from the Mediterranean and the fresh water from rivers. Naturally, this nature of the Black Sea has important consequences. The limited exchange of water prevents the deeper layers from oxygen-rich surface water. As a result, the sea shows a strong stratification, layers of water that rarely interact. The upper layer, roughly 150 to 200 meters from the top, is rich in oxygen and supports most of the life, like fish to plankton. Go deeper, then begins a dark, oxygen-free zone, extending down to the sea floor. This deeper layer, called the anoxic layer, contains hydrogen sulfide and other gases which are trapped there over millions of years. The Black Sea's geography, fed by rivers and constrained by straits, combined with its depth, creates a unique environment which you could never see in any other sea in the world. It is a living laboratory made of layered water systems, chemical processes, and trapped gases, a sea which caused both curiosity and caution. And obviously this combination of enclosed geographical structure gave rise to the myth that the Black Sea could one day explode. Let's see if it is true, and let's descend into the depths of the Black Sea, explore the layers and its scientifically fascinating character. As we move below the gray surface of the Black Sea, the environment suddenly changes dramatically. The average depth of the sea is around 1,200 meters, and you can measure the deepest point as 2,200 meters. The water is layered in a very distinctive way. First, the upper layer, which is down to about 150 to 200 meters, is full of oxygen. This layer contains almost all marine life, fish, plankton, and the predators that feed on them. This is the only zone you could see the sunlight, supporting photosynthesis and creating a rich ecosystem. Go below this and see the mysterious world. The middle layers gradually lose oxygen. These are the twilight zones where life term changes shape. Many tiny microorganisms start dominating, which adapt to less oxygen levels. Then comes the anoxic layer, starting around 200 meters and extending all the way to the bottom. No light, a total dark, and this layer contains absolutely no oxygen. Instead, you find a rich hydrogen sulfide, a compound formed by the decay of organic matter in the absence of oxygen. Hydrogen sulfide has a very specific smell, maybe close to rotten eggs, and it is unfriendly to most life forms. This chemical layering is incredibly stable. The Black Sea's limited connection to the Aegean Sea via the Bosphorus prevents this deep layer from mixing each other. Even storms or strong winds cannot mix these deepest layers. The deep water always stays as it is, maintaining a unique chemical balance. The weird question is how this layering has kept the same for thousands of years. Sediment cores taken from the seafloor show a record of slow accumulation, organic matter, gases, and minerals building layer upon layer. This is something you can never see from the surface, and yes, it is the fascinating nature of Black Sea. Let's try to understand these layers. Then maybe we can reach the key if Black Sea explodes or it is just a myth. The gases trapped in the depths are caused by pressure and temperature. They do not suddenly rise to the surface in dangerous amounts. Let's go deeper into the anoxic world in detail and see the mysterious lies down. Beneath the oxygen-rich upper layer lies one of the most unique environments on the planet, the anoxic layer. Below 200 meters, this dark, scary, silent zone stretches all the way to the seafloor. No more oxygen is found, and the chemistry of the water changes dramatically. Hydrogen sulfide is the star here on the stage. A gas produced when organic material decomposes without oxygen. Over millions of years, dead plants, plankton, and other dead organics sink from the upper layers, collected on the seafloor. What happens is microorganisms break down dead organic matters, releasing hydrogen sulfide in the process, in the absence of oxygen. This creates a total toxic environment for marine life. Fish and larger organisms are impossible to survive in this layer. Instead, only specialized bacteria and adapted microbes metabolizing these toxic gases and in that way producing energy, it is possible to live. The stability of this layer is remarkable. The limited exchange of water with the Mediterranean via the Bosphorus prevents oxygen from reaching these lower layers. Even strong storms on the surface do not reach it. The result is a chemical capsule, preserving toxic gases and compounds that affect Earth's geological and biological environment. Interestingly, something happens in this anoxic world. Gases such as methane rise slowly from the seafloor to the upper layers. They are gradual releases, not an explosion, absorbed by the surrounding water before reaching the surface. Several scientific studies say these cold seeps extensively, and none of them indicate a rapid, catastrophic release which may name as explosion. The anoxic layer also plays a crucial role in climate and global cycles. Methane trapped here is part of a larger photo about carbon on Earth, slowly interacting with oceans and atmosphere over million years period. It is a natural cycle, carefully balanced by depth, pressure, and chemistry. But is it enough to say Black Sea is not a ticking bomb by understanding the anoxic world? I believe we still need to go deep dive into this silent processing active laboratory. Let us meet the gas methane itself, how it forms, what is its function in the unique environment of the Black Sea. Methane is one of the simplest organic molecules, and it plays a very important role in Black Sea. Its chemical formula is CH4, and it is highly flammable in the certain conditions. So we may say that methane exists mostly in gaseous form trapped within bottom layer on the seafloor. The process begins with organic matter. All dead plankton, dead plant debris, and other organic matters sink from the surface into deeper layers. As these materials sink, they are buried under layers of sediment. Over time, microbes that survive in oxygen-free environment break down this matter, producing methane as an energy. Don't think methane can immediately reach to the surface. It is still captured under strong water pressure and sediment layers, forming pockets or small bubbles in the mud. In some parts, methane forms gas hydrates, looks like crystalline structures in which water molecules trap methane like a cage. See what happens that hydrates are very stable under cold temperatures and high pressures of Black Sea condition. Generally, methane slowly seeps from the sediment into the water. Scientists named it cold seeps, not like a volcano but in a controlled way. The gas rises slowly, often dissolves in the water before it reaches the surface. Understanding methane is important for understanding the way Black Sea is. Even though large amounts of methane are trapped in the sediments, still Black Sea is stable because pressure at the bottom keeps the gas in control. Cold temperatures stabilize gas hydrates. The layered water system does not let mixing. The Black Sea's methane may seem dangerous, but it is part of a balanced natural environment. Before answering whether it is a ticking bomb or not, we accept that this system is a result of stable millions of years of activity. Let us explore gas hydrates more in detail, how crystalline structures hold methane and why they are cruel in Black Sea. One of the most interesting processes of the Black Sea's deep waters is the gas hydrates. These are crystalline structures where water molecules form a cage that traps methane gas, not letting outside. In appearance, think like an ice, but they are much more than frozen water. They are a natural storage for methane. Gas hydrates form under certain conditions: low temperatures, typically above freezing, high pressures, which are found only under thick layers of sediment. The Black Sea is the perfect place for it. Go 200 meters and more, then water gets cold and the pressure is high. Here, methane formed from organic matter in the sediments is captured and stored in these crystalline cages. These hydrates are incredibly stable. They can remain unchanged if the temperature and pressure conditions are kept. Even if methane escapes slowly, it dissolves in surrounding water or forms new crystals. So can we still say a sudden catastrophic release? Let's continue digging. Oceans also have similar gas hydrates, and nobody mentions an explosion, but the Black Sea is a bit different because of its deep anoxic layer. The lack of oxygen prevents biological processes that might break down the hydrates. This means that methane can remain the same over millions of years without any risk. Scientific research shows that hydrates in Black Sea are using submersibles and sediment cores. They confirm that while methane is abundant, it is securely contained under layers of water and sediment. So we are pretty sure that the release is gradual, and some scientists say we are secure. It will never explode. But some of them do not agree with this idea. To sum up, gas hydrates are not a sign of danger, but also not a guarantee, just they are the nature of the Black Sea in a stable level. They are an unsaid agreement between chemistry and geology. So, what science explains today about the explosion myth? All people who hear the idea that the Black Sea could one day explode has an imagination in mind. But is every explosion the same? And what's the proof? The confusion arises from a simple observation. The Black Sea contains large amounts of methane at the bottom. People who are unfamiliar with oceanography accept the presence of flammable gas as an alarm sign. Such photos of bubbling mud or gas plumes rising from the seafloor in the social media trigger the perception of danger. Historical comparisons also contributed to the myth. Centuries ago, some scientists looked at meromictic lakes, small, enclosed water like Black Sea where trapped gas could erupt under similar conditions. They also speculated similar catastrophic myths. But there was a critical difference: scale and containment. Lakes are shallow and enclosed, where methane can easily break pressure quickly. The Black Sea is deep, layered, and very hard to break such pressure, which keeps methane contained. Another factor is the media. Dramatic headlines time to time spread the fear of methane, hydrogen sulfide, or deep-sea explosions, showing any scientific reference. This exaggeration doubled the myths around people unnecessarily. What scientific studies have currently? Gas hydrates are stable in today's conditions. Methane seeps are gradual, no change in last 100 years. Hydrogen sulfide remains in the anoxic layers and has no sign of leakage. In this scenario, you cannot compare volcanic or seismic movements with Black Sea. Unlike a volcano, the methane is not collected in a single bowl and ready to erupt. Instead, it is everywhere distributed over the bottom and slowly diffusing through sediments and water layers. Some scientists says even let us think about the possibility of an underwater earthquake. Methane release would be gradual and not a catastrophic explode. Another idea is that the myth of a Black Sea explosion is a story of misunderstanding and intentionally amplified by dramatic imagery and partial knowledge. They say the Black Sea is stable, and its captured methane is safely kept beneath layers of water with high water pressure. Let's examine the geological foundation of the Black Sea, its tectonic history, and think about even a deep-sea earthquake can trigger a sudden explosion. Not only does the Black Sea possess its own chemistry and biology, but also its geological history. Its foundation was shaped over millions of years by tectonic movements, sedimentation, and sea level changes. The Black Sea Bowl formed during the late Cenozoic era, roughly 5 to 10 million years ago. Tectonic activity between the Eurasian and Anatolian plates created depressions on that region, and as a result, it is filled with water, forming the modern sea. Over time, such rivers like Danube, Dniester, Dnieper, and many smaller currents carried sediments into the bowl, slowly creating thick layers on the seafloor. Fey lines crossed in that region, and the consequences of many tectonic movement forced the unique shape. These fey lines can cause local earthquakes, but generally in the low scale and nature of these movements are such that not has an ability to trigger massive releases of deep-sea methane. Instead, they create small-scale landslides and sometimes help support shifting gas hydrate gradually. Sediments on the Black Sea floor are incredibly thick in some areas, forming 1-kilometer barrier to the bottom of the sea. These layers preserve millions of years of history, and with organic matter, minerals, and even traces of past living. The sediments also act as a stabilizing factor, keeping gas hydrates in case of a sudden release. Even in some regions where several earthquakes occur, the combination of depth, pressure, and sediment stability is still a huge protector from methane perspective. These scientists say there is no mechanism to trigger a sudden catastrophic eruption. Instead, they say this balance can stay same for millennia according to the geology of the Black Sea. Understanding the geological foundation is a key to decide even there is a real risk, or this is just a mysterious and unique issue. Its tectonic activity and sediment layers are part of a stable equilibrium, which scientists continue to study carefully. Let's examine the water circulation system, river inflows, and density differences that can give us any clue about this extraordinary sea. The Black Sea has a unique water circulation system, and this provides the stability, and this is the result of its geology and chemical layers. The sea is almost enclosed, if we don't consider the Mediterranean through the Bosphorus Strait, which has a profound effect on how water moves to understand. Also, the rivers play a major role in this unique circulation system of the Black Sea. The Danube, Dniester, Dnieper, and the smaller ones pour vast amounts of fresh water into the sea every day. This fresh water is less dense when compared to salty Mediterranean, creating a natural stratification. In the upper layer, fresh water mixes with some salt water coming inside, creating a uniform oxygen-rich environment. This is where most marine life survives, from plankton to fish and their predators that depend on them. Below the surface layer, the water becomes denser due to higher salinity and temperature changes. This density difference creates a barrier mixing between the upper oxygen-rich layers and the deeper toxic layers. Even storms or seasonal forces cannot significantly affect the balance. The deep waters, under immense pressure and with no oxygen, are kept isolated. This isolation is very important to maintain the stability of methane hydrates and hydrogen sulfide inside the sea. Without this barrier, these toxic gases at the bottom could easily reach the surface, but the natural layering stops it, keeping the system calm and balanced. This circulation system also brings to the Black Sea recycling with nutrients. Plankton at the surface grows, dies, and sinks, which provides a feeding to the microbial ecosystems in the mid and lower layers. By the way, the deep anoxic layer remains undisturbed, preserving its chemical structure for thousands of years. Shortly, the Black Sea is a layered, self-regulating system. Each river, straits, and density-driven circulation combine to perfect stability, which you will hardly find in such a way in the planet. Let us compare the Black Sea to other major seas and oceans to understand what makes it different from others. To completely understand the issue inside the Black Sea, it will be helpful to compare it with other seas and oceans around the world. For example, the Mediterranean Sea. With the connection to Black Sea through the Bosphorus, it can be said an open sea and has a higher exchange of water with the Atlantic Ocean. This big exchange allows easily mixing of water layers, preventing the form such a kind of deep anoxic zones seen in the Black Sea. Methane or hydrogen sulfide in the Mediterranean is dispersed and diluted far more easily. The Marmara Sea, another inland sea. Like the Black Sea, it is enclosed. Not much rivers are feeding it, but it is shallower and has a different chemical and biological conditions. It does not have the same thick, anoxic deep layer that keeps gases for millions of years. Take the Atlantic Ocean for a contrast. Its huge size and open circulation watch helps oxygen reaches even deeper in most areas, and methane trapped in sediments does not behave in the same way. No any part of the Atlantic Ocean has the extreme layering like Black Sea as methane storage. These comparisons clearly shows that why the Black Sea is exceptional. Its unique combination of being enclosed, having a deep basin, receiving freshwater inputs from rivers, and maintaining a stable stratification makes it almost unmatched on the map. It is a natural laboratory whom to study anoxic environments, gas hydrates, and chemical layering, which these data are impossible to gain from other seas. This uniqueness also holds the gossips about the Black Sea, will explode or not. People often want to hear interesting news, and these methane or hydrogen sulfide is a good story. So what is the reality? Can Black Sea's size, depth, and natural balance make catastrophic events extremely unlikely? Let us also check the effect of earthquakes and seismic activities on the Black Sea, and what they say us out of sudden explosion gossips. The Black Sea region is open to seismic activities. Tectonic plates, fault lines, and the complex geology of Eastern Europe and Anatolia sometimes generate earthquakes. But what effect has earthquakes on the deep waters and the trapped methane? Earthquakes around Black Sea can trigger small-scale disturbances, such as underwater landslides or shifts in layers. These seismic activities may release small amounts of methane in several regions, but the effect is gradual and highly localized. Nobody expects a mechanism to release a massive, sudden eruption of all the methane in the deep layers. The key factors here are depth and pressure. Captured methane and gas hydrates are under kilometers of water and sediment, requiring immense energy to destabilize. Stable layering. The dense toxic layer prevents gases reaching the surface in a short time. Slow seepage. Even when gas find gap to escape due to local earthquakes, it rises slowly and disperses safely in the surrounding water. Historical and modern observations shows it. Scientists have monitored methane, landslides for decades and still observing. No evidence exists of large-scale explosions happened in the history before or a rapid releases to the surface. Even major earthquakes happened in the history around the shore cities didn't affect the deeper layers. They do not disturb the deep, and no sign found yet a catastrophic release of gas before. Understanding the impact of earthquakes is essential to enlighten the myth of the Black Sea explosion. While seismic activity is real, its effect is limited and manageable, as seems in the history. The Black Sea's natural system, including its depth, stratification, and sediment layers, acted as a safety mechanism. But what about after that? What about after 50 or 100 years? Are we still safe? Let us focus on one more topic to conclude, which is scientific observations and measurements inside the Black Sea over time. Over the past decades, scientists did many studies about the Black Sea, using everything from submersibles to sediment cores and chemical sensors. These observations provide a clear photo of the sea layers and the behavior of its deep layers. The most crucial key they found is that methane release is gradual. While gas exists in sediments and gas hydrates, they do not erupt suddenly. Researchers have monitored methane seeps with underwater instruments via research ships and witnessed that gas rises slowly, dissolving in water before reaching the surface. Sediment cores reveal the ancient history of the Black Sea. It is like layers have borders and they have guardians which talk to each other over thousands of years to maintain all the system in stable configuration. Even in areas affected by small earthquakes, there is no evidence of catastrophic event in the historical record. Sea water measurements confirm stratification. As expected, oxygen-rich surface layers remain separate from the anoxic deep layers. Hydrogen sulfide and methane stay trapped in the bottom, kept by pressure, temperature, and density differences. Submersible dives and sonar mapping show the stability of gas hydrates. They form crystalline structures under cold temperatures and high pressure, which remain intact over millions of years. Even when earthquakes make some shifts slightly, the hydrates adapt and do not get trigger for an explosive reactions. All these observations should be enough to make a comment, and scientists have agreed in common point. The Black Sea is a stable and balanced system. It contains a large amount of methane and hydrogen sulfide in its depths. But in history, there is no evidence to a catastrophic case. Instead, it is a natural laboratory, quietly preserving its balance and chemical environment that continues to fascinate researchers. So, finally, we came back to the same questions. How many years left for Black Sea to explode? After exploring the Black Sea in depth, from its geography, rivers, and circulation, to its unique layers, gases, and geological history, it is clear that this sea is far more stable than myths tell for decades. The deep, anoxic layers may seem dangerous, and the presence of methane and hydrogen sulfide may sound alarming at first. But science shows that these gases are safely trapped under pressure and in stable sediment layers. The stratification of the water, the slow seepage of gases, and the natural equilibrium of the Black Sea prevent any sudden or catastrophic release. No need to fear. No explosion will happen. Even earthquakes and small seismic activity shifts cannot trigger a massive explosion. Observations and experiments from ships, sediment cores, and chemical measurements confirm this. The Black Sea has maintained its balance for millions of years, and there is no reason to expect an explode in the future. In fact, the story of the Black Sea is not one of danger, but of wonders hidden beneath the surface. It is a living laboratory, preserving ancient chemical records, hosting unique ecosystems, and quietly demonstrating the incredible balance of nature. So, while it is natural to be curious, and perhaps a little awed, by the deep mysteries of this sea, there is no need for fear. No panic, don't scare, trust the science. Let the Black Sea's secrets inspire the world. Its layers, gases, and geological history tell a story of time, balance, and resilience. A story that can be appreciated safely from the surface. As we come to a finish of our journey, please remember, curiosity about nature is powerful, but understanding its secrets brings peace. The Black Sea remains one of Earth's most remarkable environments, a hidden world that is amazing, mysterious, and happy to say that it is safe.